I trust you did well on that quiz yesterday. Students in here, for the most part, did very, very well. A few little things maybe here or there had to clear up, but for the most part, excellent. We're wrapping up graphing and moving into a new chapter today here in just a few minutes. But for now, if you would be working on the classwork, page 341, numbers 60 to 65. Page 341, numbers 60 to 65. Some of you can sympathize with those two boys. Water bottles, cups, things of that nature. Assorted drinkware. It's my foot. All right, several students finished up here. Let's take a look at these questions. And it says, on what day did Kevin do the most push-ups? Well, first things first, we need to look at the legend to see which line is Kevin's line. Kirsten?
Red.
So we're looking at the red line here. Ignore the blue line. And we just want to see, where did Kevin do the most push-ups? Kirsten?
On Thursday.
On Thursday. How many did he do on Thursday, Kirsten?
40.
40 push-ups on Thursday. Good job, Kevin. What day did Chris do the least push-ups? Okay, so obviously for Chris, then we're going to have to look at the blue line. What day did he do the fewest push-ups? Ben?
Wednesday?
Friday.
Friday.
On Friday, he had his least number. How many push-ups did he do on Friday?
25.
25. What a slob, only doing 25 push-ups. All right, so just 25 push-ups on Friday for Chris. What day did Chris and Kevin do the same number of push-ups? Corey?
Wednesday.
Yeah, Wednesday. They both did the same number. And how many did they do on Wednesday? Corey? 35 push-ups each. Let's see. Who was winning by Tuesday? Who was winning as of Tuesday? Obviously, they started on Sunday, Monday, Tuesday. Who was the winner at that point? Luciana?
Kevin.
Let's see. So on the first day, Chris beat him by 5, right? And on the second day, Chris beat Kevin by 10. So Chris is already ahead by 15 push-ups. Now on Tuesday, Kevin did 5 more, right? But as of Tuesday, he hadn't made up the gap yet, had he? So on that one day, he was the leader. But as of Tuesday in this push-up challenge, Chris would still have been winning. Does that make sense? He would have been winning by 10 more push-ups. How many more push-ups did Kevin do on Wednesday than he did on Saturday? How many more on Wednesday than on Saturday? He kept trying, and then he just kind of tapered off there at the end of this challenge. What you got, Jalen?
10.
10 more, because on Wednesday he did how many?
35.
But on Saturday he only did
25.
25. Did we really need any minor grid lines class? No, they never used them. Okay, so it looks good having them and all, but they didn't need them. Let's see, who won the challenge by having the most total push-ups, and how many push-ups did this person have? I think we can tell the winner just by looking at it. Who was consistently higher, class? Chris was consistently higher. Now, he didn't win every single day. There were a couple days, but he won enough days that, yeah, we know who won. How many total push-ups did he do? So you had to add them up. 35, 40, 30, 35, 45, 25, and 35. Add them all together. How many total push-ups did Chris do? Michael?
245.
245 push-ups. How many got all of those correct? You got all 6 answers right. Any questions on where we got some of those answers? Can you talk through that in a little bit more detail? Any questions? Flip back, if you would, now to page 339. So flip one page back. Page 339. And I want you to answer questions 29 to 32. 29 to 32 on page 339. Okay, one more graph and then we'll be ready to go to a new chapter. Good, Michael, Joel, Luciana, very fast. Hopefully accurate. Corey. Good, Elaine. All right, let's take a look at these. Number 20. Now, well, first of all, what kind of graph is that, class? Circle graph. And what do we call that little color code thing they got off to the side there? What's that called, Joel?
Legend.
The legend. And just at first glance, what type of vehicle had the greatest selection? There were bunches of these vehicles available for sale. Bryson? Sedan. I mean, half the graph, literally exactly half the graph is sedans. So lots and lots of sedans. What was the smallest group of available vehicles? What's the smallest group of available vehicles, Joel? SUVs. Not a whole lot of those. What percent of vehicles were not sedans or SUVs? They were something else. Something other than a sedan or SUV. How many vehicles in that category, Ben?
40%.
40%. Good. The 15% trucks and the 25% sports cars. If the total number of vehicles on the lot was 400, there were 400 vehicles on this massive car lot, how many of those cars were sports cars that were available for sale? Luciana?
100.
100, because 25% of 400 is 100. How many got all 4 of those questions correct also? Any questions on any of those? Anyone need a little bit of explanation? Questions at all? All right, well, we're not going to completely abandon graphs, okay? We're going to come back and review them periodically, especially as we lead up to your next test. But we are going to jump ahead a little bit to chapter 11. So jump all the way over to page 402. Chapter 10. Jump all the way up to page 402. Now, if you happen to be skimming through chapter number 9, you're like, oh, all these grids and graphing-looking stuff. You're going to cover that really thoroughly in Algebra 1. That's not something my students in Algebra 1 had ever learned in junior high before. They never struggled with it in Algebra 1. There's no reason to waste my time teaching it to you in junior high. Let's be real, you don't really care about that kind of graphing anyway. You won't care in 9th grade either, but you have to know it then because it's algebra. But I do want to help you lay a foundation for algebra because, of course, next year, what's your math class going to be?
Algebra 1.
Pre-algebra, right? Where there's going to be a much bigger focus on algebra next year, so I want to make sure you're ready for it. So we're going to spend the last few weeks of the school year. Doesn't that sound good? Last few weeks of the school year. And going over some algebra things that you'll need to understand to be ready for algebra or pre-algebra next year. Today we're going to talk about what you see there on page 402, adding and subtracting like terms. Well, let's start with this. What on earth are like terms? Well, you'll remember that a term in algebra, we talked about this earlier, is something that has like a numerical coefficient, like a 5, and then it has some variables that make up what's called the literal coefficient, something like 5ac squared. We called this a monomial because it only had one term. You remember that? But if I added something like a plus 7m, Well, that's another term. Now we have a class
Binomial.
binomial. And if I said something like -1, well, now we have class A trinomial. Now, this is just a constant term, remember? These are variable terms because they have letters in them. But let's suppose I said minus 2ac squared minus 8m plus 17, for instance. Well, now I got lots and lots of terms, don't I? But you'll notice that these two terms, and notice I included the negative as part of the term, these two terms, their letters are exactly the same. They match. Those are called like terms. You see this in your notes there. Like terms are terms that have the same variables raised to the same exponents. Like terms is the very first sentence. The like terms are terms that have the same variables to the same exponents. They're like terms. And if they match, if they are like terms, they can be combined. Like terms are those that can be combined. Now look at the little chart here off to the side on page 402. 2a squared, negative 8a squared, like terms. 5x, 12x, like terms. Negative 1y, you see what I did there? Negative 1y, there was an understood 1, and positive 5y. Positive 5ab, positive 6ab, positive 2xy cubed, positive 13xy cubed. Like terms. Stay exactly the same letters. Does that make sense? Now, are these like terms anymore? They got the same letters, but see, this a is squared and that a isn't. They don't perfectly match. Or if this was a 7m to the fourth and that was a negative 8m cubed, are they like terms now? No. But as I originally wrote it, these two are like terms. And like terms can be added. It's kind of like, think of it this way. You remember the word problems back when you were a kid? If Johnny has 5 apples and Susie takes 2 apples, how many apples does, was it Johnny, have left? 3, right. Now, if Johnny has 5 apples and Susie takes 2 oranges from somebody else, does that have any effect on Johnny and his apples? No, because she didn't take any of his apples, okay? Apples, oranges, they don't combine. But apples and apples can combine. 5ac squared, take away, or negative 2ac squared, is going to leave us with a 3ac squared. Makes pretty logical sense. Here I've got, think of this as literally 7 M's. I don't know, how many have ever played a Scrabble or a game like that where there's little letter tiles? Imagine if, you wouldn't actually want this in Scrabble, but if you had 7 M's, okay? Imagine an M being a thing. And somebody takes away 8 M's? Well, technically then, what do we have, class? Negative 1 M. And notice here, these two, do they have the same variables raised to the same power, class?
Yes.
They have no variables, which means they have the same variables, right? For instance, if Corey's broke and Luciana's broke, do they have the same amount of money? Yes. 0. They have nothing, okay? Well, these are also like terms, class. So we can combine them. They're also like terms in that they have nothing with them, no letters at all. Negative 1, positive 17, class.
16.
Positive 16. Like terms are terms that can be added and subtracted. Here's the key. When you add like terms, let's just suppose I got 5 apples and 2 apples. What do I got, class? Big hands. Anyway, 7 apples. Okay, 5 apples and just 7 apples, right? Not 7 apples squared or anything. It's just 7 apples, right? When you add like terms, write this off to the side. Only add the numbers. Don't mess with the letters. Keep the letters the same. Add the numbers, numerical coefficients, if you want to be exact. Add the numbers, keep the letters the same. Add the numbers, keep the letters the same. Now, when I say add, class, I do mean add. Like if the signs are the same, add and keep the sign. If the signs are different, subtract, keep the sign of the greater absolute value. We're still applying signed number adding here as we add a positive 5 and negative 2, subtract, keep the sign of the greater. And the positive 7 and the negative 8, subtract, keep the sign of the greater. And the negative 1, positive 17, subtract, keep the sign of the greater, right? We're doing the addition of signed numbers there. But notice you don't mess with letters. Just keep it in AC squared. Just keep it in M. Make pretty good sense. Seem pretty easy, especially this late in April, this close to the end, not blowing anybody's brain. Question? Look at the example problem. Actually, look, if you would, first at the little red thingy in the middle of the page there. I got 4a plus 6a plus 3b. Do you see how the 4a and the 6a are like terms? They can combine. 4a plus 6a class?
10.
10a. Now, does the 3b have any friends?
No.
No, there are no like terms for the 3b. He's lonely. He may be lonely, but he still exists. Okay? Just because you're lonely don't mean you don't exist. Just because you have no friends don't mean you don't exist. 3b ain't got no friends, still exists. Keep the 3b. Don't lose the 3b. It's not like 4a and 6a, 10a. 3b doesn't have any friends anyway. Get rid of No, we don't get rid of the lonely one, okay? Look at the example at the bottom now. They got a 2x plus 3x plus 5. Well, which two terms can be added, class?
2x.
2x and 3x. They add, you get 5x. What do we do with the 5? Keep it. Just keep it. Look at the next one. Got a 7b cubed plus a 4b squared, negative 10b squared, negative 4b. Which two are like, class?
4b
squared, 10b.
The 4b squared and the what?
10b
Negative 10b squared. That negative is part of that term. So I got a positive 4b squared and a negative 10b squared. What does that combine to give us?
Negative 6.
Negative 6b squared. Good. Now, the 7b cubed ain't got no friends. What do we do? Keep it. What about the negative 4b? Ain't got no friends. Keep it, right? Keep the things that don't combine with anything else, but only combine what actually would combine together. Let's do some of these real quick together, top of page 403. Not trying to insult your intelligence or anything here, but you're going to write either like or unlike. Number one, class, are those two terms are? Unlike. They letters ain't the same. Number two, they are? Like. So number one, they are unlike. Number two, they are like, because they got the same letters. Number three, class? Unlike. Yeah, the letters don't match exactly. What about number four? Those are like terms to each other. Number five? Also like terms to each other. What about number six? Unlike. They both have x's and y's, and there's a square somewhere, but the wrong one squared the second time. So they're unlike. They would not combine. But look at number two. We said they're like, correct? What would we get if we added number two, a negative 5x and a positive 10x, class? Keep the sign of the greater. Positive 5x. Look at number 4 right below it. We said those are like terms. 6xy, negative 5xy.
Positive 1x.
Positive 1xy. Or we could just say xy. Yeah. Positive 1xy. Remember we said a 1 could be an understood number and a positive could be an understood sign. We could just say xy if we're really lazy, and I am. Look at number 5. Ooh, what would we get if we added an x squared and a 5x squared? 6x squared. There's an understood 1 in front of that other x squared. So it's not a 0x squared plus 5x squared. It's a 1. 1x squared plus 5x squared would give us a 6x squared if we added them. For number 7 through 14, write like or unlike. Write like or unlike. Finish out that exercise. Another word, by the way, for this is similar terms. Similar terms, but like is shorter to write. So I like instead of similar. Hush. Make music on your own YouTube channel, not mine. All right, class number, actually just go around the room. Number 7, Joel. Like. Number 8, Michael. Unlike. Number 9, Ben.
Unlike.
Unlike. Number 10, Corey. Like. Number 11, Bryson. Unlike. Number 12, Griffin. Oh yeah, he skipped. Just kidding. I hope you feel better soon, Griffin. Number 12, Luciana. Like. Number 13, Elaine. Unlike. Number 14, Jalen. Like. Let's look at the like ones together. Number 7, Kirsten, what would I get if I added those?
Negative 6x.
Negative 6x. Good. Stop the thumping. Number 10. Those are all like terms. What would I get if I added those, Joel?
23b squared.
B
Cubed.
cubed. There we go. 23b cubed. Excellent. Number 12. What would we get if we added those, Michael?
18 negative w.
So I got 18w, and then I got negative, and what's the understood number here?
9. 17. I'm at negative 17w.
Keep the sign of the greater. Which one's greater, the positive or the negative?
Negative.
The negative is bigger. Negative 1 is bigger than positive 8.
Positive.
So we should get what? Class help.
17.
Positive 17W. You can think of it this way. If you have 18 W's and I take away one, like let's say a team wins 18 games and then the NCAA comes in and says, nope, you cheated in that game. We forfeit that win. Now they have 17 wins, 17 W's. Does that make sense? You awake in there? Poor Michael. Number 14. What do we get if we add the 9AB and the 9AB? Those are like terms. What do we get here, Ben?
18 AB.
18AB, good. Now for numbers 15 through 23, have we simplified the polynomial or haven't we? Simplified means we've combined what we can. Unsimplified means we ain't combined stuff yet and we need to. Number 15, is that simplified, Corey?
No.
No, we could combine to get what?
Positive.
Positive 12x. Number 16, is that simplified or not? Bryson?
Yeah.
Yes, those don't combine together. You can't do nothing with that. That's fully simplified. Number 17, Luciana?
No.
No, it's not simplified?
Yes.
Is it simplified or not simplified?
It's not simplified.
Wait, so we could combine those together then. To simplify means to make more simple, right? To make, so for, if something's really, really big and nasty, we try to combine things together and clean it up a little bit. Could we clean anything up on 17?
No.
No, since we can't clean it up, it is already as simplified as it can get. Does that make sense? It is a simplified expression. Yeah, the negative term, the not, is throwing us off here, isn't it? Number 18, is it simplified or is it not simplified? Elaine?
Simplified? No, it's not. Okay.
It's not simplified because we could make it more simple, couldn't we? We could combine a couple of friends here to get what?
-5D.
Negative 5D. Now the other positive 5 can't combine with anything, but the two D's could combine, so it was not simplified yet. We could simplify further. How about number 19, Jalen? Is it simplified or not simplified?
No.
It is not simplified because we could still combine what?
18P.
To get?
24P.
24P.
Positive 4.
And then we'll keep the plus 4 because it ain't got no friends. But we still keep it. We don't get rid of it. Looking at number 20. Is that simplified or not simplified? Kirsten?
Not simplified.
What can combine?
The -3n and positive 4n.
Right, to get what?
Positive 1n plus 2v.
Good, we can combine to get the positive 1n, and then the plus 2v has no friends. That just sticks around. What about number 21? Let's come back to Luciana. She wants some redemption here. 21, Luciana, is that simplified or is it not simplified?
Simplified?
It is simplified. Nothing combines. We're done. It just leave it alone. What about number 22, Joel? Simplified or not?
Simplified.
It is not. There's a little bit that we can combine. Do you see it?
16 and 2.
The 16 and 2, because they both got literally nothing with them, which makes them alike in that way, because they got nothing. And so, what do we get?
18 and -4r.
Good, I like that he said -4r instead of -4r. He wouldn't have been wrong the other way, but I like using the word negative there. I will train you to do that when you get to 9th grade. 18, -4r, very good. What about number 23? Is it simplified or not simplified? Elaine wants some redemption as well.
Not simplified.
Not simplified, because we can combine what?
7x squared and 5x squared.
To get
12 squared.
12x squared.
Yeah.
Plus the 3x, because that just kind of keep it around, because, you know. All right, questions on all this? We see what we doing here? All right, your turn to try some of these. I want you to do just 25 to 37, the odd. Do not do the evens yet. Just 25 to 37, the odd, here on page 403. Make sure we're on the right track. So don't do them all, just do the odds. After all, why would we want to have a trinomial if we could whittle it down to just a monomial or even a binomial? Smaller is better. It's just easy. You look at it. Get rid of stuff. Combine stuff. Several people finished with the odds. Take just a little longer though if you're not done yet, that's okay. Just the odds, 25 to 37. Snap, crackle, pop. Rice Krispies.
Oh.
Hear a loud popping and Jalen just falls over. All right, looks like we're finished. Let's take a look just at the odd numbered problems together here and see how we did. Number 25. Ben, what did you get?
6Z.
6Z. Number 27. What did you get? Michael?
3D.
Well, that's number 28. We were looking for number 27. Joel?
2B.
Or not to be. I was just kidding. It is to be. Number 29. What did you get? Let's go back to Michael. You went down the middle column,
Yeah,
didn't you?
yeah.
Instead of doing the odds. You're really tired, aren't you? It's okay. The YouTube audience knows you're usually really sharp, so you're allowed to have an off day. Number 29. Corey, what would we have?
15D.
15D. Number 31, Bryson. 7W cubed. You didn't need your help. 7W cubed. Number 33. I think I accidentally skipped Joel.
11X.
No, I didn't. You were the to be or not to be. Never mind. 11X. Number 35. My bad memory. Kirsten, what'd you get?
7A.
7A. And then number 37. What did you have, Jalen?
13B to the 5th.
13B to the 5th is correct. How many were perfect on the odds? Or the 2 or 3 odds you ended up doing? All right. All right, questions on any of those odds? Any questions? I did not get that answer. Can you please help me understand how I should have gotten that? All right, do the evens now. Now do the evens. Want to make sure we were off to the right on the right start. We'll do the evens now. 24 to 38. Evens. Keep the letter the same, just combine the numbers. Signs are the same, add and keep the sign. Signs are different, subtract, keep the sign of the greater absolute value. This time. We can't handle our water bottles. Oh my, some people's kids. All right, let's take a look at these together. And Elaine, number 24.
12X.
12X. Number 26, Luciana.
29W.
29W. Number 28, Michael.
3D.
3D. Number 30, Michael.
1X squared.
1x squared. Or we could just say x squared. We could leave the 1 understood if we wanted to be lazy, but it's not wrong to write the 1. It's just not lazy. Number 32, Ben.
4y5.
Well, how do we say it though? 4y to the 5th. How do we say it?
4y to the 5th.
There we go. Number 34, Joel.
Y.
It is not. Kirsten?
0Y.
0y. But think about this for a second. What does 0y mean? What does it mean when something's up against something else, class? Multiplication, right? 0 times anything equals 0. So we could just say 0 or donut. 0 is our answer. Though if you say 0 y, it's not wrong. Now, Joel, the problem is if I just say y, that implies we have what number here? A 1. But of course, we had 2 plus 1 minus 3, right? So 2 plus 1 is the 3, minus 3 is a 0. So yeah, we'd have to say either 0y or just 0 for that one. That one was tricky. Number 36, let me come back to you now, Joel. 1w squared. Or we could just say w squared. And number 38, what you got, Bryson?
10n cubed.
10n cubed is correct. Very good. Questions on that? Look across the page again, if you would, please. And that last little paragraph in the blurb on page 402 talks about the conventional order. When we talk about something that's being conventional, we just talk about what's ordinarily done. Okay? So when something is unconventional, it's kind of out of the ordinary or a little bit weird, right? Like, for instance, could you do your 12-minute run backwards?
No.
I mean, you could, but that's very unconventional. Could you skip your 12-minute run?
Yes.
I mean, you could, but you'd be wasting energy. It's not conventional, and people would say that's weird, right? We usually use the word weird. Unconventional is a fancy way of saying weird. So if someone's ever told you, you're such an unconventional child, what they really mean is, you're weird, dude. All right, so anyway, so conventional just means what's normal, okay? So mathematicians have made sure, by the way, math, as I've said before, it's really thinking the thoughts of God after him. God is an orderly, mathematical God. That's why our whole universe that he designed is designed mathematically. So since we have an orderly God who designed everything mathematically, mathematics should have order to it. So when we write a polynomial, there's a proper order that we want to write it in. There's two key orders. Look at the second line of that last paragraph, and you see where it says alphabetical order. Highlight alphabetical order and then the example next to it. 4a plus 3b minus 2c. Highlight it or underline it. Alphabetical order. 4a plus 3b minus 2c. In a polynomial, if the terms have different letters in them, we generally write them in alphabetical order. Does that make sense? Sometimes, though, our polynomials will only have one letter consistently, like just x. That's the most common example. And there, the next line, you see it says descending order according to the exponent. Descending order according to the exponent. Mark that and the example. 7x cubed plus 5x squared plus 8x. 7x cubed plus 5x squared plus 8x. Do you see that the x, it's all x's, right? You can't alphabetize x, right? It's like, you know, the old blonde joke. How do you keep a blonde busy? Give her a bag of Skittles and tell her to alphabetize them. Anyway, that's... Jalen just got it. You can do the same with a bag of M&Ms. It's a great effect. Except sometimes there's M's and W's and they get confused. Anyway, Corey's like, W's? For the record, Jalen's not even blonde. Okay, anyway. For those of you. But anyway, and then other people would say, blonde is not a hair color, it's a state of mind. Anyway. Anyway, I'm getting myself in trouble here. I am losing YouTube subscribers. Okay, so anyway, 7x cubed plus 5x plus 8x. You can't alphabetize this, so what we do is we call descending order. When something descends, it's getting lower or getting smaller, right? Like, you know, your paper airplane, it descends after you throw it. It gets lower and lower and lower. Or, you know, a batting average. You keep striking out, and the batting average just descends. It gets lower and lower and lower, like all the guys on my Cardinals team. Anyway, we did finally win last night. But descending order. So do you notice here we have x cubed, there's 3 of them, then x squared, there's now only 2 of them, it's smaller, and then finally just one of them is listed last. That's descending order. So there's only one letter, we might write it in descending order, or with that note, look right below it, it says the constant would be written last. So in the next example, you see right below where you just marked in your books, 4y squared plus 6y minus 8. Well, we have y squared, that's 2 y's. Then y to the first, that's only 1 y, and then the y is gone. You can't get much lower than gone, okay? So 2 y's, 1 y, no y's. Make sense? And there, it's gone. So look back across the page now with me, page 403, and look at number 39. They want us to write this in conventional order. Well, because you have different letters, what's the conventional order for different letters?
Alphabetical.
Alphabetical order. So how would we rewrite number 39 in alphabetical order, Kirsten?
9A plus 6B.
9A plus 6B. Number 40. Once again, we have different letters, but we also have a constant. And I said that the constant is written last. So if we write the constant last, how would we rewrite number 40, Joel?
8x minus 3y plus 3.
Perfect. 8x, negative 3y, or you could say minus 3y, and then put the plus 3 at the end. Just put the constant last. Does that make sense? Look at the next one. Number 41. They're all different letters, so that means we need to put them in alphabetical order. Now, this is where you're like, oh shoot, my alphabet. A, B, C, D, E, F, G. Okay, so anyway, as you're thinking through the alphabet here, they did at least give you letters that are far apart from each other in the alphabet. That'll help a little bit. And how would we rewrite 41, Michael?
Okay. Negative 5D plus 4W plus, plus 2N plus 4W.
Good, and I like that Michael said negative 5D. That negative is part of the term. So don't just put a 5D at the beginning, it's a negative 5D. And then he had to put a positive 2N. You say, there's no positive on the 2N. Oh yeah, there is. There's the understood positive. So negative 5D, then the positive 2N, and we'll leave the positive 4W at the end. Now on number 42, we don't have different letters, but we can have a descending order here. How would we rewrite 42 with a descending order, Elaine?
Is it 4x plus 7x squared plus 5?
Well, you put the constant at the end, which is good, but we want the powers to get smaller. So we would want to put the biggest power of x first. So try it again.
So 7x squared plus 4x plus 5.
There we go. The 7x squared, so there's two x's at the beginning. Then the positive 4x, there's only one x in the middle. And then the plus 5, there's no x's at all at the end. You see how the x's are getting smaller? Fewer and fewer x's. Okay, so similar thing on number 43, Bryson. How would we rewrite that in descending order?
Okay, W squared plus 8W minus 11.
There we go. W squared, positive 8W, negative 11. Though it's not wrong to say W squared plus 8W minus 11. Good. Number 44. Want to put that in descending order, and Elaine wants some redemption. Okay, go ahead.
4k2.
Well, 4K2.
4k squared.
There we go, 4K squared. You almost blew your redemption from the beginning.
4k squared. Negative 14k. Positive 18.
Great job. 4K squared, negative 14K, positive 18, the constant at the end. How about number 45? They're different letters, so we need to put them in alphabetical order. Jalen?
Negative g squared plus n2 m.
Don't pull in a lane now.
n squared plus 12.
There we go. And good. Keep the negative with that g squared at the beginning, then the positive m squared, and then the constant goes at the end. What about number 46, Ben? How would we rearrange those?
Negative 23m plus 7a plus 14n.
Well, what's the first letter alphabetically here?
A.
So we should put that term first. So try it again.
7a plus 14n plus negative 23m.
Well, think through the middle of your alphabet. A, B, C, D, E, F, G, H, I, J, K, L,
M, N, O, P.
L, M, N, O, P. So what comes first, M or N?
M.
M. So one more try. Third try's the charm.
7a plus negative 23m plus 14.
There we go. 7a, then the negative 23m, then the positive 14n. You notice it's a lot harder when the letters are close in the alphabet, aren't they? It's like, wait, which of those comes first? So just think through that little portion of the alphabet. Some of my favorites are like when they have like the QRST, that little portion. It's like, wait, which QRST? Yeah. Anyway, number 47. What should we have for this one here, Luciana?
4y to the power of 4
Or 4y to the fourth is how we could say it.
plus 16y to the power of 5 and negative 8y.
Now we want the powers to go down, to get smaller, right? That's descending order. So we want to start with our biggest power first.
16y to the 5th power, negative 8y, and positive 4y to the 4th power.
Okay, so I think I see what you're doing here. You're focusing on the coefficients. Don't look at the coefficients, look at the exponents. I want the y to the 5th term to be first. Then I want the next smaller y to the 4th to be next. And we'll let our y to the 1st or just y be last. It doesn't matter what the coefficients are, make sure the y's get smaller. Does that make sense? So the y to the 5th happens to have a 16 on it. It's a 16y to the 5th first. The y to the 4th happens to have a positive 4 on it. We'll put that next. And the plain old y happens to have a negative 8 on it. We'll put that last. But I don't care about these numbers. I care about these exponent numbers. Does that make sense when we talk about descending order? Questions on 39 to 47. Now that we've had a chance to kind of talk through these, any questions? All right, so what we need to be able to do then is combine both of these skills. Can we combine like terms, and then when we write our answer, write it in the conventional order? Does that make sense? So, 48 to 53, finish the page. 48 to 53 now, finish the page. Get your answer, and then once you get your answer, check to see if it's in conventional order. If it's not, fix it. If it's already conventional order, then lucky you, you're off the hook. So 48 to 53, combine like terms first, then put it in conventional order if necessary. All right, pencils down. Even if you're not finished, let's take a look at these together. The first thing, can I combine all three terms of the trinomial into one nice, easy term class?
No.
No, because they're not all
The same.
like terms. They're not all what?
Like
terms.
terms.
But the first two are, so I can combine 12a, positive 9a class to get
21.
21a, and then the positive 5 has no friends, so we'll just keep it. Now, is this in conventional order?
Yes.
Yes, there's only two terms. The constant is at the end. This is the correct way to leave our answer. Look at the next one. Are they all like terms?
No.
No, but which two terms are like, Luciana?
Negative 5x and positive 18x.
So I can combine those to get what?
13x.
Positive 13x, or just 13x. And the positive 4 has no friends, but we still keep it around. Is this in conventional order class?
Yes.
Yes. We've got the constant term last. Looking at the next one, we can combine the two m terms together, Corey, to get 14m. And of course, we'll put our negative 6 at the end, even though it has no friends. How many got the first three of these correct? 48, 49, 50. questions on this top row. Let's look at the second row now. I can't combine all of these, but I can combine these two. 4y and negative 2y then gives us
2, positive 2,
positive 2, keep the
Y.
letter y. There we go, positive 2y. 8z has no friends. Now, if we're smart, we think through before we write it down. Where should I write the 8z? Before or after the 2y, class? After, because we want alphabetical order. So if we'll think through the conventional order as we're writing, it might save us a little bit of time. Looking at this next one, number 52, I've got 1, 2, 3, 4 terms, but only a couple of them combined. Which ones combined, Joel?
The 4a and the negative 3a.
Those combined to give me what?
1a.
Positive 1a or just a. Now, what should be the next term I write down if we want to keep conventional order, Joel?
Negative 2c.
Negative 2c, and then we'll finish by writing the
Positive 4d.
positive 4d. One more, let me turn the camera here so we can see the sideboard. And over here, what do we combine together? Is this the same problem?
Yeah.
I definitely copied something wrong here. Let's make this a 4p negative 16w, positive 8w, positive 3. I got two problems combined there in one. Which terms combine here, Bryson?
Negative 16, or negative 16W and positive 8W.
Good. Those two things combine to give me what?
8W, or
Okay.
negative. Or
Negative 8w. Good. Negative 8w because we keep the sign of the greater. Now, where should I write the 4p, class? Before or after the negative 8w? Before, because p comes before w in the alphabet. So alphabetically, conventional order says put the p, then the w. Where should I put the positive 3? At the very end, because we always put the constant at the end. How many had that answer for number 53? All right, questions on this? You're going to practice with this in your homework this evening, page 404. Do numbers 1 through 30 all. Page 404, do numbers 1 through 30 all. Page 404, 1 through 30 all. Once you got that copied down, you are dismissed. Have a wonderful rest of your day.